Hello my dear subscribers, hello YouTube. Today I'm gonna show you the simple PLC program. This is my panel. For time saving, I created hardware configuration and also inserted HMI panel into my project. In previous lessons you learned how to create hardware configuration and add HMI panel to your project. So I don't do it again. Let's introduce to you this program. This is Siemens KTP400 HMI panel. Here I have two tanks. Tank 1 is full with water and tank 2 is free. I want to discharge tank 1. Bring this water from tank 1 to the tank 2. The water levels measured with level sensors. Level sensor measures water level of tank 1. Level sensor 2 measures water level in the tank 2. I have three buttons. Start button's contact is normally open. When I press this button, this contact's closed. And when I release, it becomes normally open again. Okay? Stop button is normally closed. When I press, it opens, and when I release, closes again. And the reset button is also normally open push button. Here I have two LED lamps. Green lamp indicates that system is running. Red lamp indicates system has fault. When the system running, this green lamp turns on. When the fault occurs, this red lamp flashes. I have electronic valve outside of the tank 1. Water waits here. When I press the start button, this valve energizes. When this valve is energizes, change to green color. And water goes from electromagnetic valve to the pump. And waits here. And running lamp indicates system is running. After 10 seconds, water pump energizes. When water pump energizes, water flows from tank 1 to the tank 2. So you can see here, water level in the tank decreases and water level in the tank 2 increases. In this tube I have two sensors. One is PT100 type temperature sensor and one is pressure sensor. This sensor also works for 20 mA signals. If fault occurs in the program, system stops immediately and this fault lamp flashes for 1 second turn on and 1 second turn off. You can ask a question. When fault occurs in this program? When temperature over than 30 degrees, when water pressure inside the tube goes over than 10 bar, also when the water level in the tank 1 is 0, no water inside the tank 1, and we press the start button, the error lamp will flashing again and we can't start our system. Also, when our system works, water flows from electromagnetic valve from the pump, but where is water? Our pressure sensor don't measure water pressure. So this means tube is broken. For this reason, system stops and fault lamp flashes again. In this window we can see current temperature value, water pressure value, last working time. If we press the start button, if no fault occurs, system works 60 seconds. After 1 minute, system stops again. Okay? Here you can see the addresses. In the PLC programming, we need additional addresses. For time saving, I added this in the default type table. Today I will write the PLC code of this system and simulate it. Let's begin programming. For programming, I go to program blocks, main OB1, and that networks. Program will run from network 1 to the last network. First of all, I need to measure water level inside the tank 1 and tank 2. So, because we use PLC simulator, we must use move blocks. You can add this block from here also. Block move. Okay. I want to connect level sensor 1 tag from simulator. So this one is maybe 2. I write here maybe 2 from level sensor 1 to the lesser one. And here from level sensor 2 to lesser 2. This means I move value from memory word 2 to the memory word 14 and from the memory word 4 to the memory word 16. I want to measure water temperature and water pressure inside this tube. So I need to add another move instructions. Connect this tag. PT100 sensor from simulator, memory word 6. Memory word 6 to the this tag. PT memory word 18. I write here PT. Click OK. And pressure sensor. Pressure sensor from simulator, memory word 8. To the pressure sensor. And connect these outputs. This network cannot be stayed opened. We must add here a coil. Give a tag. Move is OK. M0.5. M0.5. This one is analog network. Click to save. In the next network, what we need to do? We need to start our system. So I go to add open contact and set reset instruction. We can add this instruction also from BitLogic operations tree and select this one and drag and drop to here. Okay, now we can delete it. Give an address of start button. Start button is M0.0. This one is run command over stop button. Yeah, we must add negative trigger and give an address for negative trigger 1. Okay. This stop button is normally closed, so this open contact of the stop button is also closed. And when we push to the stop button or wire is broken, this negative trigger passes to the reset input of this block and run command turns on. When we started and run command is on, the running lamp will indicate program is running mode. Okay, we need to add coil and give an address running lamp. So go to the next network. Here what we need to do, then I press to the start button, electromagnetic valve energizes immediately. So I need to add open contact and the coil for the valve and run command. After what's going on, when the valve is energizes, water flows from this tube to the pump. The time started timing. After 10 seconds, water pump energizes. Let's do this. Close this 3, and go to the timer operations. We need to add here on delay timer. Click twice on it and data block creates automatically. Click the OK button. This timer has 2 inputs and 2 outputs. In is enable input. PT is preset time value. I need to give 60 seconds to the preset value. True output is digital output. What will turn on after 60 seconds. Time is end. And YT value is analog value. So we need to connect this output to the current time value tag. Data type is time, 32-bit value, MD10, okay? What we said, after 10 seconds, water pump energizes. Give a new arrow, put here comparator operations, greater or equal, and another coil. What we need to do, when the current time value equal or greater than 10 seconds, the pump will turn on. I want after 60 seconds system stopped. So I need to add an open contact, connect it, and give an address times end. While and pump network. One is start and stop command network, and new network is fault network. What I said, if the water temperature is greater than 60 degrees Celsius, fault turns on. I need to add a new set reset instruction to here. Put here comparator greater than instruction and give an address. When the PT value is greater than select data type, you can see here PT data type is word, not integer. But this instruction has only integer value. Integer also 16-bit data value. So we can select integer here. Give a tag name for the fault. If fault occurs, the fault lamp goes turn on. And another greater than instruction. And this one is pressure sensor value. This means when pressure sensors over than 10 bar, fault is turned on. If the water level inside the tank 1 is 0 and we want to start our system, fault turns on again. I need to add another open contact, give an address run command when I starting our system, and water level of the tank 1 equals to 0. We can't start our system. If the fault occurs, we can't start. Okay. After what we said, if we started our system, valve and pump energized, but water pressure is 0 here. So we must stop our system. When we have a run command, put another arrow, put here and open contacts of the valve and the water pump. And another comparator instruction greater than, and give an address of current time value. If then is low to 20 seconds, we say. This means if we started our system, electromagnetic valve energized, water pump works after 10 seconds, and when water pump energized after 10 seconds, water pressure still is 0, fault lamp indicates again. Okay, I want this red lamp flashing 1 second turns on, 1 second turns off. So we can use here clock memory bits. When you go to the device view, click device on PLC and go to the clock memory. By default, clock memory is not activated. You can activate it and give an address. We can add memory byte between 0 to 255. So I want to use memory byte 100 and click OK. Close this window. I added clock memory bit, clock time for 1 second, so M100.7. Okay. This on relay timer current time value is milliseconds. I want to see in the HMI for the second values, not milliseconds. So what I need to do, I need to divide this current time value to the 1000. Go to the mass functions, put new arrow here. This block divides input 1 to input 2 and writes it to the out. Current time value 1 divides to 1000. Data type is double integer. This is also 32-bit data value. Okay, and write it to the last working time tag MD22. Excuse me, I have a little problem. Connected these wires to reset input. We need to connect these wires to the set input. Okay, so delete this wire and connect to the set input. Okay, and when the fault will reset, if we press to the reset button. When I press to the reset button, this block must be resetted. What I want to do, pressure value is not equal to 0, is less than or equal to 1 bar. Select data type as integer. Because if water pump has a problem, water will flow with lower pressure. 1 bar is lower pressure for this project. Now I can connect these tags to the HMI panel graphics. And also you must know, right click to the PLC, go to assignment list. And in this assignment list, you can see what memory bytes we used in this project and what is free, what input bytes, output bytes. Timers counters is used in here. Okay. This blue light shows what addresses is used and what is free. Now we can simulate our program. Select PLC, click the compile icon. You see here, not errors, not warnings. Okay. And click the start simulation button. Because I'm using Profinet communication, I must select TCP/IP. Okay. And click to load our program to the simulator. Simulator like real PLC. Now we must click to run program, and after click to HMI icon, compile, not errors, and click to simulation icon. Connection established. What we need to do? We need to add these addresses for simulation. Okay. Now we need to add input-output variables. I go to PLC tags folder, insert input variable, memory byte 0. Okay. Memory byte 0.5 is true. We can see it here. Go to main program, select our PLC, and go to online mode. If there is everything is green colored, so it says okay, no problem. This one is in 0.5, move block is okay. That's true. And what I need to do, I need to add the output variable. Okay. Analog values from memory word 2 to memory word 8. Click to insert input variable, memory variable 2, memory word 4, memory variable 6, and insert input variable, memory word 8. Give a name of this address, current time value MD10, data type is time. Configuring our simulator is finished. Close project tree also, and open here simulator and VNC runtime. So what I need to do? We said tank 1 is full with water. Level sensor 1 100%. Okay. Now you see here. For better understanding, I click to here right button, modify, display format, decimal. Okay. Now you see 100. Modify decimal. Modify to decimal. Okay, our program works fine. Wait start command. Just I click to always on top. PT100 sensor temperature shows us 0 degree. The weather temperature 23 degree. Now you can see it here. Okay, when water not inside, this measures weather temperature. We can to start our system. I click to start button. Start command comes. Valve energizes. Water comes from valve to the pump. and waits here. After 10 seconds, pump energized and water comes to this tube. Now you see, after 20 seconds, water flow is not detected here. You can see fault network, reset system run command, valve energized, pump worked. You see here, last working time. Water pressure was lower than 1 bar. For this reason, this fault block energized. Clock time memory bit works and fault lamp indicates here. We can reset our program and start it again. Started, valve energized, 5 bar, okay, and water decreases from tank 1, water increases in the tank 2. You see? Now fault becomes again. Temperature value over than 30 degrees. You see in the fault network, modify display format to decimal, and you see this line works because the water temperature over than 30, it's 31 degree. This fault block works again and fault lamps flashing. I go to press reset button. Block resetted, but input of the block still is true. So, and when I release this button, fault appears again. Give another error. While our system stopped, the water pressure goes down. Water temperature also. And now we'll start again. I click the start button. System works. Water decreases from tank 1, increases to tank 2, and water pressure goes to 12. System starts again, and fault indicator flashes. Come to fault network, and we see here this line activated. Modify display format to decimal, and you see when pressure sensor value over than 10, fault becomes true. And when I click the reset button, I can't reset this program. When pressure goes down, I can reset program. Give another fault. If water level in the tank 1 is 0 and water level in the tank 2 is 30%, I push the start button. What's going on? System won't start. Water level of sensor 1 is 0, and when I press the start command, this block energizes again, and fault indicator comes here. I need to reset and add water to the tank 1. Give another problem to the system. If water level in the tank 1 is 40% and in the tank 2 30%, I click the start button. System works. After 10 seconds, pump energized. Water comes from here. Pressure, you see, water level goes to down in tank 1 and up in the tank 2. After in the tank 1 is 0, you see here fault appears again, and here is no water, water pressure goes to down. Okay, fault appears for that reason, because I started our system, run command I have, and the level sensor 1 becomes to 0. System protects our water pump. Here is no water and pump can't working. So we need to reset and add water to the tank 1. Now I want to give another fault. Water level in the tank 1 is 90%. And in the tank 2 is 70%. Okay? Press the start button. System works. After 10 seconds, water pump works. Pressure becomes here 6 bar. Temperature goes to up. Decreases tank 1 for 20%. And tank 2 increases for 20%. Okay. After tank 1 decreases for 10%. Tank 2 increases to 10%. Tank 2 is full, but our system still working. Why? We can't protect the system. Not fault indicator here. So we need to do that. Close this window. And go to offline mode. If I have a run command, give another comparator instruction, copy this one, add arrow here, paste it, and connect to this wire. So what this means, if I have a run command and tank 2 is full, fault indicator appears again and system stops. Okay, now I can download this code to the simulator, finish, go to online mode, and click to HMI panel and start simulation. Okay, close this tree. Let's do this again. Click to start button. System started working. After pump working, pressure appears here. Water decreases in tank 1 and increases in the tank 2. After decreases in the tank 1 and increases in the tank 2 for full. Okay, now program works fine. System stopped and fault indicator flashed again. And you see here tank 2 is full with water. For that reason system stopped. Because system is stopped, water pressure goes to down again. Now we can reset. If the system is not have a problem, works only 60 seconds. Give another example. If tank 1 is full, tank 2 is free, and I go to start our system. System works fine. After 10 seconds, pressure becomes here. Tank 1 is decreases. This running indicating lamp indicates system is running. Okay. Now you see system stopped because I used here a timer value for stopping our system. Start stop network, and here time is end command. Okay. When the timer value becomes to 60 seconds, time is end output activates and stops our system. Thank you so much for watching this video. If you like it, press the like button, share with your friends, share with your colleagues, and click the subscribe button for new lessons. If you have a question, you can ask me, write comments, I will answer everything. Thank you.